There are two ways we can divide polynomials. One is with synthetic division, which I have in another video. The other is long division. Now, here's the pro and the con with long division. The good thing about long division is it will work on all rationals. Anytime we're dividing two polynomials like this, we can use long division. Synthetic, frankly, is easier, but it can only be used in certain circumstances, which you can see and hear about in the synthetic division video. But long division does take a little more time, but it will work every time. So that's kind of the pro and the con. Okay, before I do this example, I want to remind you how you used to divide just with numbers. So let's say I'm just doing random numbers here, 235, and we're dividing it by 7. If I were to do long division, back when I was in 4th grade, my 4th grade teacher would always make us say, divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. So those 4 steps are the way to do it. So I just want to show you how that is the exact steps we did with numbers, and then that's the same thing we'll do with these polynomials as well. So first we divide. 23 divided by 7. How many times will 7 go into 23? That would be 3 times. So I've divided. Now I multiply 3 times 7. Then I subtract those. I get 2. Then I bring down the 5. So I've divided, multiplied, subtracted, and brought down. Then I repeat. So 25 divided by 7. 7 will go into 25 3 times. So I've divided. Then I multiply. 3 times 7 is 21. Then I subtract. And there's nothing to bring down, so 4 is my remainder. So I would have 33 and 4 sevenths, because I always put the remainder over top of whatever I'm dividing by. So 33 and 4 sevenths. That may seem basic or silly, but I really want you to see how the steps we'll take with long division with polynomials is really the same steps we did there. So we'll need that space, so I'm going to erase that. And now we will tackle this problem. So the reason we know we have to use long division on this one is because that exponent in the denominator. If we have an exponent other than 1 on x, then we have to use long division. So we're going to write it just like we would the other type of division. X squared plus 4 going into 2x cubed. And note, there is no x squared here. So to help keep things in line, the best thing to do is put a 0 x squared in there, because we want to make sure we don't end up with like terms not being in the same place. Plus 6x minus 7. So again, please note, if there's a power of x that doesn't have a term, then you need to put 0, whatever x power that is, to make sure you keep things in line as you're subtracting and doing all those things. So I have it set up. And just in case you're wondering, you may notice over here we are also missing an x. If you want to write x squared plus 0x plus, that is fine, that won't cause any problems. But the reason, the spot where it's really important to do so is really what's inside the division. Outside it's okay to do, but it honestly doesn't matter either way. Sorry about that, random stuff popping up. Okay, so now let's divide. So we do the same 4 steps we did before, which is numbers. We divide, we multiply, we subtract, we bring down. So we start by dividing. We start by dividing 2x cubed, this first term right here, over x squared, the first term right there. So 2x cubed over x squared. So x squared can cancel out, 2 of the x's can go away. That leaves me with just 2x. So dividing 2x cubed over x squared gives me 2x. Now I multiply. 2x times x squared is 2x cubed. My program's having trouble keeping up with my writing. Give me just a moment. Hopefully it'll catch up. Okay, let's try this. Huh. Spinning plasmid of death. Oh dear. Okay. Alright. So again, we're multiplying. So we have 2x times x squared. That gives us 2x cubed. And then 2x times 4 is 8x. Now notice, I'm going to put that over here because I want to keep the like terms together. So since 2x times 4 is 8x, I'm just going to keep in line with the x's. So I divided, then I multiplied, now I subtract. 2x cubed minus 2x cubed cancels out. 0x squared minus, well, there's no x squared there, so that's still 0. 6x minus 8x is negative 2x. And then I will bring down the negative 7. So one thing I want to make sure is clear. I usually put parentheses around this part because it's really important to make sure you remember to subtract all the pieces. So I'm subtracting 2x cubed and I'm subtracting 8x. Alright, now that's actually as far as I can divide. I don't need to repeat the process because x squared doesn't go into negative 2x. Since x squared has a bigger power than 2x, it won't divide any farther. So this is actually my remainder. So I take my remainder and I put it over top of my original denominator, which is x squared plus 4. So my final answer is 2x plus negative 2x minus 7 over x squared plus 4. I realize this may not feel great right now, but give it some time. We've got 2 more examples. Help you sort it out. Okay, next up. 6x cubed plus 25x squared minus 12 divided by 3x minus 1. This is another one where we would have to use long division because of that 3. That coefficient of 3 in front of x means synthetic division, which is in another video, won't work. We can't do synthetic division when x has a coefficient other than just 1. So we'll do 3x minus 1, and we're dividing 6x cubed plus 25x squared. Notice again we have no x, so I'm going to put a 0x in here to help make sure I keep everything in line. And subtract 12. So that missing term, there's no x, but I'm going to fix that by having the 0x. So here you'll see the process again. We divide, multiply, subtract, bring down. So we start by dividing 6x cubed, the term in front, divided by 3x, the term in front. So I'm dividing these two. 1x cancels out, making it x squared on top, and 6 over 3 is 2. So I have 2x squared. Again, I'm just doing 6 over 3, that's 2. And then x cubed divided by x reduces it down to x squared. So 2x squared will go on top right here. I've done my dividing. Now I multiply. I multiply 2x squared by both pieces. 2x squared times 3x gives me 6x cubed. 2x squared times negative 1 gives me negative 2x squared. Then I subtract. Make sure to put parentheses around it so you know to subtract both pieces. 6x cubed minus 6x cubed is 0. 25x squared minus a negative 2x squared means really plus 2x squared is 27x squared. And I'm going to bring down the 0x. So I divided, I multiplied, I subtracted, and brought down. Now we get to repeat. So now I'm doing 27x squared divided by the 3x. 27 divided by 3 is 9. And I can cancel out one of the x's, leaving me with just x. I don't know why that random line went across there. Who knows? Okay. But 27x squared over 3x is 9x. So 9x is what goes up top here. And I need to multiply. 9x times 3x is 27x squared. 9x times negative 1 is negative 9x. So I've divided and multiplied. Now it's time to subtract. 27x squared minus 27x squared is 0. 0 minus a negative 9x is positive 9x. And then I bring down the negative 12. So I divide, I multiply, I subtract, I bring down. Now I have to repeat again. 9x over 3x. The x's just cancel each other out, and 9 divided by 3 is 3. So I put a 3 up here. 3 times 3x is 9x. 3 times negative 1 is negative 3. So I've divided and multiplied. Now it's time to subtract. The 9x's cancel. Negative 12 minus a negative 3, so it's really plus 3, is negative 9. And that is my remainder, because there's no x, so I can't divide any farther. So negative 9 is my remainder. So my answer then is 2x squared plus 9x plus 3 minus 9 over 3x minus 1. Because you got to remember to put your remainder over top of your original denominator, which is 3x minus 1. Last example. X cubed minus 4 over 2x plus 5. Again, this one would require long division because of that 2 in front of the x. When there's a coefficient other than 1 in front of the x, you'll have to use long division. So I'll do 2x plus 5 divided by, and notice we've got lots of missing terms here. We have x cubed, but then there's no x squared, there's no x, and then we have minus 4. So I start by dividing x cubed over 2x. So I can cancel out one of the x's, leaving x squared, but really I end up with a fraction here because it's just 1 divided by 2, so it's 1/2 x squared. So I'll put that right here. I do 1/2 x squared times 2x, that gives me 1x cubed, because the 1/2 and the 2 cancel out. X squared times x is x cubed. And then 1/2 x squared times 5 will give me 5/2 x squared. Now I subtract. The x cubes cancel. 0 x squared minus 5/2 x squared gives me negative 5/2 x squared. Then I bring down the 0x. So I've divided, multiplied, subtracted. Now I bring down. Now I need to divide again. So I'll do negative 5/2 x squared divided by 2x. So one of the x's will cancel out, leaving me just x. And the negative 5/2 divided by 2 is negative 5/4. And you can do that part in your calculator if you need to. You can use the decimal if you prefer, negative 1.25. So we get negative 5/4 x right here. Negative 5/4 x times 2x is negative 5/2 x squared. Negative 5/4 times 5 would be negative 25/4 x. I subtract, the x squareds cancel, end up with a positive 25 over 4 because I'm subtracting the negative x minus 4. Whew, one more time. We got to divide, multiply, subtract, bring down one more time. So we do 25/4 x divided by 2x. The x's cancel. 25/4 over 2 gives us 25/8. So we'll put 25/8 on top and multiply that. 25/8 times 2x gives us 25/4 x. 25/8 times 5 will give us 125 over 8. So we subtract. Forgot the x there. The x's will cancel out. So that goes away. And let's see, I'm going to get my calculator to help me here. We need -4 minus 125 over 8. Missed the 2. -4 minus 125 over 8. So -19.625, or I'll just stick with the fractions, it'll give it to me, -157 over 8. So that is our remainder, -157 over 8. So that will go up here and be placed on top of our original denominator, which is 2x plus 5. So our final answer, sorry this one's pretty messy with fractions, but 1/2 x squared minus 5/4 x plus 25/8 minus 157 over 8 divided by 2x plus 5.